one of the things we need here is that if you want to connect these persons, rules and actions and devices and whatever, they would need to have an address, like a telephone number, right? Right now the addresses on the internet basically are IP addresses. So we know which device to connect to, and then we basically go to the application. When we go to the virtual internet and we have entities, the entities themselves need addresses so they can talk to each other. And basically we come up with a new DNS. The DNS is basically the dictionary, where the directory where all the IP addresses are in. We need something similar, we call it DNARS, which holds the U3 ID addresses, the addresses for the virtual entities. We currently look at a different kind of structure than DNS, which is not using that many nodes, at least physical nodes. The system should produce real-time identifiers. We're coming from the one space-time objective. We want to connect everything in the here and now. It should be scalable. So in the beginning, millions of transactions per second, but they should go up pretty fast. And I'm also making a lot of shortcuts over here, but please allow me to do that, otherwise we will be sitting here tomorrow. We start anyway with 7 different socio-economic continents working together on that directory structure. Now, what we typically see in blockchain is that there's many physical nodes, and it really requires a lot of time for those physical nodes to come to a new state. One of the reasons for that is that the physical nodes basically have to communicate with each other. So a signal has to go from one node to the other.
Sorry, Floris, to interrupt. I don't think that mic is on.
No?
Yes, it is.
Yeah.
Well, because it changed when Floris just put it closer.
Okay.
Because down here it just didn't.
Yeah, so you have
Other
some.
close.
I have to speak
Yeah, no, you
almost
have
in.
to.
Okay. So what we basically see in normal blockchain technology, a signal has to go from one node to another, to another, to another. Now, the speed of light, 300,000 kilometers a second approximately, through a cable is 200,000 kilometers a second. With a circumference of 40,000 kilometers, that means light can travel 5 times a second around the planet without touching, processing, or doing anything. If we want to get into real time, that means we should not be having a lot of roads to travel for a signal. Hence, we cannot have too many physical nodes. Now, people feel that not having too many physical nodes has a problem to do with distribution of power. But what we actually could do, we could create virtual nodes, which means users themselves become virtual nodes and become controllers of the physical nodes in turn. So rather than having a network with 100,000 physical nodes copy-pasting the same information, when an update, a fork, governance of 100,000 nodes is quite complex. Hence, we take a look at a system that requires less physical nodes in order to have a more real-time experience, but have inclusive governance of users rather than of hosts of physical nodes. That makes a bit of a difference. Now, what we try to do, we control the cryptography. With cryptography, you have a kind of root or master key, and then the other key pairs are basically derived from that. The question is, who controls the root key? The moment we can control that root key together, actually nobody can individually, or also it's extremely hard to come up with situations to control that. We have a way that we use cryptography that works for all, and that's one of the real problems we currently have in the internet. I'm simplifying a lot of things here, but that's also for the sake of speed and presentation. The moment we have a cryptographic tool, and we can make our own entity by creating our own identifier and our own key pair. That means we basically can create our own identity. When we create our own identity, we're not dependent on an app or an application provider that can press delete, which means killing the virtual body of somebody else. Just think about it. Who can delete you? Can you delete yourself, or can delete somebody else yourself? In many cases, people will not do it. But who ultimately holds the power to kill your virtual body? It should be yourself, right? So this is a very important step change. When we go to an internet where we basically control our own virtual bodies, and we determine whether we can press delete or not, that's very relevant. We should be empowered to do that ourselves. At the same time, we can also go into constructs where we can create hierarchies. For instance, a government can do something, like institution government. But also when it comes to trust. There's many different ways that we can operate multi-signature, hierarchical structures, peer-to-peer, and we can combine them. Which basically means we can provide any governance we want, whether it is peer-to-peer, self-sovereign, and this means that the system itself is agnostic, governance agnostic, which is quite an important feature. So we're not saying you have to implement like that, you have to do it like this. No, this is what we can determine individually and together. When we compare traditional blockchain with DNS, with what we're now doing with the virtual internet and DNARS, is that we try to create a system that works in real time. High performance because of the less physical nodes. These things are possible. Attribute access and control, something that the current internet or blockchain doesn't have. Semantic interoperability, jurisdiction detection, which is important. You want to have rules and regulations applicable in real time. Check that. Assurance levels. Well, there's some other technical stuff. Not going in too much detail. What we try to do is to create an internet that starts from entities. An entity basically having identifier, which is just an address. Then I can make that address with a semantic vocabulary into a glass with water, a table, a person, anything I want. And what I want to do afterwards, I want to bring the entities together in a transaction, in a context, and they will change attributes with each other. When we take a look at the internet architecture nowadays, and you basically have the TCP/IP model and the OSI model. Here again, let's take a look how it is built from physical layers to abstract layers, just like evolution, right? So physical layers, the highest layer we currently have is the application layer. That's why we have the Internet of Application. Everything is defined within the application context. But the moment we put the entity, the atomic layer on top, we take the atoms, the entities, the information outside of the context of the application and make them global, they will start operating in a different way. Now, we've done this before. We have an internet with a directory at network layer where we have addresses. We just don't have an entity layer with entities and addresses. So it's just applying the same internet architecture that we've done in the past. We just add a new layer and we work towards atomic entropic levels. The interesting thing is that this is where we came from. This was the inspiration we got. We had to connect all these applications together, right? Which was a nightmare, all the spaghetti, and how to maintain the spaghetti. The moment the information itself is not bound to the application anymore, but is standardized, it means any application with the right access and control management rights can work on the entity. There's no need for spaghetti anymore. Because we are in the virtual world, it's quite easy to create things virtual. It's just I have to basically create the concept. If I have the concept person, I can create a virtual person. what we do, we create a vocabulary. And I'll come back later to that, how we do that. But this vocabulary is an open vocabulary. We can add words, and with that, we can create these concepts virtually. The big question is, how are you going to map this whole virtual internet? Because you need a dictionary. And the beauty actually comes in when we use the same verbs as that we saw in the evolutionary and creation context. To be, to have, to want, to do, to can. To can has two meanings. And we use interrogatives. And this is a way where we can pinpoint down quite a lot of things already in context. And then we go further. Let me explain. If I have a to be entity, that's a person or an organization, something at least exists. The demand side of the market. There is a to can, an ability, the supply side of the market, the classical response. To can as in allow, the rule. And together we bring people, organizations, products, goods, services, demand, supply, and conditions into and to do an action, and we come to a new state. We can do a transaction like this. Doesn't matter, it's an agnostic model. We can change states from all kinds of perspectives, whether it is in insurance, in logistics, social, doesn't matter. When we take a look at transactions currently, we typically see that transactions are being processed in a segregated way. So first we do a payment, then there's a delivery, then there's a tax payment. When we bring them together in the here and now, in a kind of group chat, we basically can clear and settle them all together at once with the same information. What we basically do, and here is where we can create out of shared content and shared intent. We have who, what, how much, when, where information. Not everybody has to see that out of the service providers. For instance, when I buy a book from Amazon, what I do, I basically tell Amazon, this is the book I want, etc., etc. But I don't need to give my details to Amazon. I can, right now, Amazon is the first in the chain of processes, so I have to give all the details to Amazon. But the moment I give my bank an instruction to send money to Amazon, Amazon doesn't need to know who I am. It just knows money is paid for the book. The logistics party knows my address. Amazon doesn't. So whether we can actually share more with sharing less, and I can keep more control of my data. What is more important is that all the services come together on the basis of shared content, but also shared intent. And here's where intentional co-creation starts. You put in your requests, and you see if you can match them. And you match them together at the same time. So, one of the big changes we have right now, when we are in the Internet of Applications, my data is with the big application providers, right? Google, Twitter, Facebook, Amazon, Samsung. If somebody wants to know something about me, are they going to me? No, they go to the application providers. They own my data. What if we work on an Internet of Entities, and I have a phone number, and just like in a regular phone call, you call me and you want to know something about my health data, I can decide to give it or not to give it. I'm in control of my own data. The good thing is that when we use this system, we own and control our data, but what is also nice, we are immediately GDPR compliant, because I've given my consent to share the data. So it's not only easier connecting, we're GDPR compliant, and we really go to a user-centric internet instead of an application provider-centric internet. What we try to do with the foundations is to work on common identification, common understanding, and common processes. Obviously, we want to keep that open. This is not too simple because we've seen this in the past that what we try to develop is, thank you for the idea, let's make a business model and try to make it as symmetric for myself, one company or another. You need to have a certain minimum momentum for society to catch on and say, hey, we're going to use this as a new open free internet protocol or an open new free internet dictionary that we can start using. And fortunately, we do make progress, but we have to be very careful in really disclosing it. And we expect to disclose more for this internet that we deem to believe has to be there for all to become available as such. So FOCAFET focuses really on the intellectual property. DNR's about the infrastructure. Now,
So you mentioned focus on the intellectual property. Who owns the intellectual property?
basically, FOCAFET publishes the intellectual property, so everyone can use it for free. But we need a foundation that manages the process and publishes the protocol, etc.
You have a test network up and running.
We have certain things up and running, but right now we want to be a bit careful in sharing. We do that with parties typically where we have agreements with. Not to share it, we build it further in order to roll it out the moment we feel there's sufficient traction. And that's basically our experience, but I think Stuart can also mention similar experiences he had. We actually started developing completely open source, but we realized that people were just doing free shopping, trying to fork and rebrand stuff rather than really help and reinforce the community going further. But yeah, that's the dynamics of open source development. You actually need some governments putting in or philanthropic money trying to support that. Otherwise, it's quite hard to get rid of.
Have you spoken to George Soros?
If he's willing to help, yeah, we can talk about that.
We're going to be talking about physical product flow. Would it be good to add waste disposal on the end, so we've got more of a circular economy mindset?
We'll come there. Yeah. That's one of the examples we're going to discuss. Right now, so I just want to show a bit how this internet is working. And we just take the supply chain. When we have a supply chain, we have several parties represented in the supply chain: the farmer, the cooperative, the trader, producer, retailer, consumer. Typically what is happening is that information on the product resides within the application of the stakeholders. But do the applications talk with each other? No, they don't, or very limited. So what we're trying to create here is a virtual barcode, a virtual product, a telephone number for a product that everybody can access. So we're not connecting applications, we just make the applications connect to a virtual entity. I don't have it here, but basically the virtual barcode is a barcode that is also represented in physical form that cannot be copied. But we're working now on technology that you can create and read these barcodes with your mobile phone, and it's universally unique, can't be copied, and hence very strong authentication of the product.
So what you mean can't be copied?
When you try to copy, there's abnormalities in the printing process that can be detected, and you can tell what you try to copy by print is not the same as the original.
So if you take photocopy,
Doesn't work.
it not be the same
No, it's not the
as
same.
as
There's a
original.
difference in paper, there's a difference in lithographic parameters, paper, print, and some information that we put into it.
And digital. And if you try to copy it digitally,
Really, the costs are quite prohibitive.
sorry.
The costs are quite prohibitive to make copies that are identical and are I cannot say too much about it at this point in time, but we're developing that right now.
Interesting.
We make that as an open standard as well.
Who's we, Forrest?
People that work with the Vocafed Foundation. So we're a community of individuals and organizations developing these things. And we will start disclosing some of these solutions also in larger consortia.
So with individuals primarily or organizations?
Both. From multinationals to individuals.
So is this like a sort of open source closed group of open source?
Close open source.
Yeah. So you have two models of open source. One may be very blunt, the open source bazaar method where everybody is shopping, yeah, and the cathedral model. We're using the cathedral. We develop closed in order to open it when there is sufficient momentum and traction in order to know that it will sustain itself. Because the moment it doesn't sustain itself, all the efforts, you have to really restart it or rebuild. So because we have seen the attacks on our open intellectual property in the past, we have basically turned wiser because of those experiences and say no. We make sure there's sufficient momentum, and when the momentum is there, we basically bring it out into the open.
So what people on open source are kind of adding all kinds of bits of functionality that are corrupting the original purpose or the original functionality that is meant to be captured there.
Well, first of all, they try to build a proprietary solution around it, rebrand it, and if you have all these variants of our standard,
Then you can't tell.
then you can't come to that standard. So we've had some larger IT organizations where we basically had to say, sorry guys, we would like to work together, but here we close the door.
But you're going to have some sort of governance committee to avoid forks. Always.
Well, this is why we need the momentum, and traction is probably the best thing to have, what we see with the current internet protocols. It's very unlikely people start to fork them. TCP/IP, there's 1,000 ways to improve on that, but who's going to fork it? We will get traction. So you need to have a certain momentum for it to be used and tested, which is a bit of it's a bit of a challenge. We could be helped by philanthropic money and by governments. That's a way to get there, but also use cases and try to build a bigger community that we're doing right now. And we're positive towards the end of the year, beginning of next year.
Shouldn't the corporates that you're putting that are participating, shouldn't they be contributing to your core funding? So
That's also what they do.
right.
Yeah.
So they sponsor it and
We're
their
sponsoring
brainpower.
and we're working a bit together.
Okay.
I can't disclose too much about that, and I have to also admit it's not that much in order to manage expectations. But at least there are some positive developments that are growing.
Do you know the TV program Silicon Valley?
I heard this remark before today.
The show?
No.
Yeah, the show.
I don't.
But
I don't.
literally, the episode the last two episodes were about their efforts to create a new internet.
Yeah.
The company involved called Pied Piper, and how there's an attack by, because the 51% thing,
Yeah.
So there's literally an attack by the arch enemies of the system and the Chinese government. So it's kind of interesting that you're talking about this right now, as that is there in popular culture.
They heard about him.
Yeah. So, well,
That's why we have a voting mechanism that works differently.
A lot of the stuff they do on that show breaks the laws of physics. So it's entertainment.
well, let's hope this doesn't break the laws of physics.
Perpetual motion machines don't work.
Come on.
Good. So what we try to achieve here is to come up with this virtual barcode that everybody can dial into the product. So that virtual barcode is nothing more than identifier, this telephone number, with some basically additional information. You can see it a bit like this. So we dial into the product, right? And I want to know what's in it, the height, net weight, all kinds of information. I know about its whereabouts, but that could also be there. What we organize basically is a dictionary with extension numbers. So when I dial into an office and I want to speak to John, I just have to dial extension 123. If I dial into the product and I want to know net weight, I dial the extension for net weight. If I have access to that, I get that information. And this is also how we can attribute access and control management. Some people may see net weight, others may not. And also the information itself, it can be virtual one product, but it can be stored in several digital environments. Right? So this is a way how we basically create virtual entities in a distributed environment where we can all work in process, where we allow each other to do things, or not. We can do the same for organizations. Information about who may access what, contact details, what the organization owns, and for people, I think.
Can I ask us a question in terms of the sort of combinatorical? Because it kind of all makes sense if everything is a unique entity, but it just the complexity of transactions would be just huge. So aren't you in a kind of environment like this? Aren't you going to need to have groups? And then each group
I'll have to leave you because my battery has run out. So sorry about this. I'm just going to leave you. And follow me again on a good friend's mobile, who I'm just going to post this conversation, which is continuing. And I will be posting the next half later.